Hi, I'm Dr. B. Ravikumar, Associate Professor, Department of ECE, Aeronautical Engineering. In this lecture, I'm going to discuss about tabulation method. So far, in the previous lecture, I explained about the Karnaugh map method. This Karnaugh map method is so simple as long as the function variables are less than 5 variables. What if more than 5 or 6 variables? It is somewhat awkward, it is somewhat difficult to search for the adjacent ones under the shape of those prime implicant adjacent ones and make them group, and then we can minimize. So in order to avoid those difficulty, we can go with tabulation method. In this tabulation method, we follow this specific step-by-step procedure. By following this step-by-step procedure, we can first find out the prime implicant and then minimize the Boolean function. The first applied this tabulation method by Quine and then updated and modified this tabulation method with the McCluskey. So it is also known as Quine McCluskey method. The tabulation method of simplification process consists of two parts. First one is exhaustive search for prime implicant and then finalize minimum number of literals from this prime implicant table. The determination of prime implicant using exhaustive search. The list of minterms that is specified in the Boolean function in the first column. Then apply the minterm matching process. The process compares with each minterm with every other minterm. And then if two minterms differ only one variable, then the variable is removed and the remaining variables to be considered. Again, we can compare with one minterm with the other minterms and then check is there any one variable different. Likewise, we can compare with one group of minterms to the other group of minterms, and then this process is repeated for every minterm until no further elimination of the literals. That can be seen now. The given Boolean function of the using tabulation method we can minimize. In order to do those tabulation minimization for a given Boolean function, we have to follow these four steps. Step 1 is whatever the minterms given are listed in the Boolean function, we have to group them. Group binary representation of minterms according to the number of ones that it contains. And number 2, or step 2, any two minterms in that groups differ from each other by only one variable which can be combined, and then unmatched variable removed. The minterms in one section or one group are compared with the other groups that next section down only. Group 1 with respect to group 2 only. Group 2 compare with group 3. That's it. And then in step 3, the term of column B have only 3 variables. In the second column, we have 3 variables because one variable is eliminated. And then searching and comparing the process is repeated for the terms in column B to the column C. Again, we can minimize one different variable and then remaining 2 common variables. So after that, we can uncheck terms in the table from the prime implicant. Let us see for step 1 first of the given Boolean function. The given Boolean function is f of x, w, x, y, z is equal to the minterms which are given in the Boolean functions are 0, 1, 2, 8, 10, 11, 14, 15. It is 15. So now As I said in the 4 steps, the first step is group the minterms according to the number of ones inside the binary representation of that minterms. So we have these minterms. When we group in a column A, this is column A. In this column, we can representation of those minterms according to the number of ones inside in the minterm. Let us see 0. It contains 0 number of ones, so we can group it as a group 1. And 1 to 8 having single number of ones in the binary representation, so we can group this 3 numbers, 3 minterms into group 3. And 10, 1 0 1 0, 2 number of ones, so we can group it into group 3. And 11 and 14 having 3 number of ones, we can group it into group 4. And 15 is having 4 number of ones, we can group it into 5. So in column A, we have 5 groups of numbers. We can divide into 5 groups based on the number of ones in the given Boolean, like a given minterm. What is the next step? Step 2 is exhaustive search process started. So take the first group, compare with the next group, next section, next group down only. Group 1 compare with group 2. While we compare with these 2 groups, check with one variable change. When we check with this one variable change, so here it is 3 bits are zeros and 3 bits are zeros, only 1 bit change. So in this case, we can cancel or we can remove that 1 bit change variable and then consider all the common variables. So in this, we can group those corresponding decimal numbers. It is required to represent a decimal number in the left side, each minterm represented by decimal number, so that we can, while grouping, we can easily group those numbers. So 0 1, while grouping 0 1, we can have only 1 bit variable change, so that can be grouped into 0 comma 1. This can be represented by W under W 0, X 0, Y 0. These 3 variables are common, but Z is different variable. We can represent it by mark, like a mark, like icon. And then another group, if you see this 0 2 also having one variable change. This is the one variable change, remaining all are common, remaining 3 bits are common, so we can also group it into 0 comma 2 into one group. So what are the common variable? W bar, X bar, Z bar, but Y is different, so we can represent it by hyphen. And 0 8, we can have 0 8. In this 0 8, first variable is complemented to each other, remaining all are same. We can take that hyphen 0 0 0. Next, while searching this group 1 to group 2, next move forward with group 2 and group 3. Group 2, group 3. In the group 2, we can have 1 to 8 and group 3 10. Is there any 1 bit variable change in 1 and 10? No. If you see that 1 and 10, 1 001, 1 0 1 0, there will be more than 1 bit change. And 2 10, if you see the 2 10, 0 1 0, 0 1 0 is common, only 1 bit change. This 1 bit change, we can take the group 2 comma 10 is one group. We can take the variables hyphen 0 1 0 and then 2, 10 is over. 8, 10. If is there any 8, 10, so when we check this 8, 10, we can have 8, 10, 1, 0, 0, means here it is only this bit is changed. So then we can consider that 8 and 10 as 1, 0, hyphen 0. That is then done with this group 2 with group 3. Then move forward with group 3, group 4. Group 3, group 4. This bit is change bit. Like this variable, last z variable is one variable change. Remaining will be same. So we can group that 10 with 11 and group with 10 with 11. So 101 and dash. Next group with 10 with 14. We can have this bit is change. This bit change. Second bit. So remaining will be same. So we can 1 dash 1 0. So now we move forward. Just to search. Continue with the G4 and G5. In this G4 and G5, only, sorry, it is 1. 15 means 4 ones. So this 1 bit change. So this 14 and 15 also make group. We can have 1, 1, 1 dash. So now it is finished in the grouping in the column B. So it is required to checkbox, like it is required to mark whatever the min term which covers with the next group down. So 0 is covered as 0, 1 is there in the group column B. 0, 1 is grouped. So 0 is covered. 1 is covered. In the second row in the column B, 0, 2 means 2 is covered. 0, 3, 0, 8 means 8 is covered. And 10, 2, 10 in the column B. So 10 is covered. 11 is covered. 14 is covered. 15 is covered. Now, again this process is repeated to check the 0, 1, 0, 2, 0, 3 with the second group in the column B, 2, 10, 8, 10. So in order to do this, compare these minterms, group of minterms from group 1 to group 2. So let us check with 0, 1 with 2, 10. Is there any common? So it is very common to check this column B with a simple hyphen. First check the hyphen. Is there any fourth bit z variable hyphen in the second group? Yes, no hyphen is there. So no need to check. Then 0, 2 in the third bit position, there is a one hyphen. So is there in third bit position hyphen in the second group? Yes, it is. So then we can compare these two. So 0 to 8, 10, if you compare, first bit is change, remaining value common, like this one. So 0 dash 0 is common. 0 dash 0 is common. So we can group 0 to 0 to 8, 10. 0 to 8, 10 we can represented by 0 to 8, 10. So first 0 is common. Sorry, 0, 1 is different bit, means we can make hyphen. Remaining will be same. 0 dash 0 is same. Next 0, 8 having first bit having hyphen. Is there any first bit hyphen in the second group? Yes, it is. Here it is. So 0, 8 to 10. 0, 8 to 10. This will be make this numbers as one group. So again 0, 8 to 10, we can have hyphen in the both groups, 0 in the both group, but this bit is changed and 0 is same in the both groups. This is one. So in order to do this column C, what are the groups we covered? 02 is one group is covered, 08 is covered, 08 is covered, and 210 is covered, 810 is covered, but 01 is not covered. 01 is not matched with any groups in the group 2 in the column B. Next, this searching process continue with the group 2 with the 3 in column B. So 210 compare with 1011, 210 compare with 1014. 210 is there. So it is very easy to compare. First hyphen is there in the third column, second and third column no. So no need to check. And the third bit is hyphen. Is there in third bit hyphen in the third column, third row, third group in second column? Yes, it is. Oh, sorry. So it's not there. Third column is not there. Next, so it is, there will be no common variable, like two variables are common in the group 2 and group 3. Next, check with group 3 and group 4 in the column B. First, last bit position hyphen in this. So here is last bit position hyphen. So we can compare. We can group them. 10, 11, 14, 15. This will be one group. What are the common variables? 10, 11, 14, 15. 10, 11, 1 is the common. 0, 1 is the dependent variable, so we can mark it as a dash. Next, third bit is 1 in both groups, and the last bit is dash in both groups. So one bit, this one is changed. Second bit is only changed. That's why I can make this hyphen. And next 10, 14, 10, 14 and 14, 15. 10, 14, 14, 15, 11, 15. We can also have here two groups. One is 11, 15. In the 11, 15, 1 dash 1, 1, and 14, 15, we can have 14, 15, 1, dash. So in this case, if you want to check 10, 11 and 10, 14, compare with 11, 15 and 14, 15. So 10, 11, 14, 15 we have done already. 10, 11, 14, 15. 10, 11, 14, 15. So in this case, the last hyphen is there in last hyphen. Compare with the 14, 15. So this hyphen 10, 11, fourth bit hyphen. So 14, 15, fourth bit hyphen. So we can combining together, we will get 1 dash 1 0. This dash means that's one bit change. Next, is there any other connection group? This 10, 14 and 11, 15 having same second bit position hyphen. So we can make that group 10, 14 and 11, 15. So 1 dash. Here is this 10, 14, 11, 15. Where is the bit change? Here it is bit change. So that last bit is hyphen. Remaining will be same. 1 dash 1 is the same. So in order to do this grouping column C, in the 10, 11 is also covered. So we can put tick mark. 10, 14 is also covered. Put tick mark. 11, 15 is also covered in the tick mark. 14, 15 is also covered. Tick mark. So what are all the uncovered groups? Uncovered groups is nothing but prime implicants. So what are all the uncovered means? So let us see now column C. Once checking the column C, in the column C there are two groups. One is 0 to 8, 10, 0, 0, 8 to 10 is one group. 10, 11, 14, 15, 10, 14, 11, 15 is another group. When we compare these groups, just to search for this group, is there any combination to have one bit change? No one bit change. So if you compare with the group 1 and group 2 in the column C, there is no minterms that having only one bit change or one variable change. So they are also unmarked. So what are all the unmarked we will see now. That can be represented as that they are all represented by prime implicant. That is what this one not covered. This one, sorry, we can represent it not tick mark. We can represent it by like star. This is not covered. This is not covered. This is not covered. This is not covered, and this one is not covered. So there are 5, but among 5 in the column C, first group both having same minterm representation. Group 2 in the column C also same, both are same prime implicants. So we can consider one prime implicant instead of two prime implicants. So what is the final Boolean function or final prime implicants? F is equal to, this one is first, we can take this one. 000 dash means W bar, X bar, Y bar. And so first group in the column C plus dash 0 means X bar, Z bar. Because under X 0, under Z 0, that icon represent not included. Next group 2 in the column C, 1 dash means W dash Y, like 1 means Y, WY. W bar, X bar, Y bar plus X bar, Z bar plus WY are the prime implicants. This is first step. In the first step, we can have exhaustive search to find the prime implicants. Sometimes these prime implicants also possible to minimize. Again, there is further minimization happen. This can be done by using prime implicant table. We can use the essential prime implicant concept, then from which we can minimize them. So that is, we will see now how to do that further simplification process. In the further simplification process, we can consider the prime implicant first. We can consider the prime implicant. What are all the prime implicant? W bar, X bar, Y bar, X bar, Z bar, X bar, Z bar, sorry, W, Y. What are the minterms groups? The group of minterms that cover this prime implicants. The covers prime implicant. W bar, X bar, Y bar by make this group is 0, 1. So we can also write down. Those groups. What are all those groups? This is one group. So we can represent it by this one is 0, 1. This X bar, Z bar represented by this one 0 to 8, 10. 0 to 8, 10. And this one is represented by 10, 11, 14, 15. 10, 11, 14, 15. Now in the second column, we can take the all the minterms in the decimal number 0128, 01, 128, 10, 11, 14, 15. 10, 11, 14, 15. So in this case, we will take the prime implicant table. This prime implicant table, we can find out the further minimization of the Boolean function. Let us check. What is the first minterm? 0. This minterm is covered in the first prime implicant, so we can put mark, cross mark. And other prime implicant like other minterm covered in this first prime implicant. This is first prime implicant. 1 is also covered. In the second prime implicant, 0 to 8, 10. 0 to 8, 10. So we can take the cross mark. 0 to 8, 10. And third prime implicant covered with the minterms 10, 11, 10, 11, 14, 15. If you see these columns, column wise in all minterms, so what are all these single cross marks in the columns? Single cross marks. So this is single cross mark. This is single cross mark. This is single cross mark in the entire column. Only single one cross in the entire column. Single cross, single cross. Those single cross are essential prime implicant. Single, then it is called essential prime implicant. These essential prime implicants we need to consider. So here, while crossing this one, essential prime implicant. So whatever the essential prime implicants, so we cover this, all the prime implicants are not. Essential prime implicant 1, it is covered in prime implicant first prime implicant w bar, x bar, y bar. So we can put cross mark. Second prime implicant, this one is covered. Second prime implicant, this is essential prime implicant covered. This one, so we can put the cross mark. This is covered in the second prime implicant, so take the cross mark. This is prime implicant covered by third one, so we can take this. So these all prime implicants covered the first one. So these all three essential prime implicants are covered this prime implicant. These essential prime implicants are covered second prime implicant. This first essential prime implicant covered first prime implicant. So whatever the all essential prime implicants are covered all the three prime implicants. So we can no minimization. So whatever the prime implicants existed in this exhaustive search, that will be the answer. So f is equal to w bar, x bar, y bar plus x bar, z bar plus w, y. And we will see with the next example with further minimization also happened with this after exhaustive search. So in this case, we will check with this even with the Karnaugh map. So for the sake of that, I am taking the 4-bit Boolean function, but this tabulation method is useful for more than 5 or 6 variables. But in order to check this answer, so I am taking the 4-bit variable. So if I am checking this one with a 4-bit K-map, we know that how to take the 4-bit K-map in horizontally 2 variables and vertically YZ. We can take the gray code order 00, 01, 1110, 0001, 1110. And what are the minterms? 01. Like we can take the minterms 0, 1, 2, 8, 10, 8, 8, 9, 11, 10. Like 11 also there. 8, 10, 11, 10. 14, 15. 12, 13, 15, 14. So how to group this one according to Karnaugh map? According to Karnaugh map, first check the all ones, 16 ones in the square boxes. If it is not there, then go to 8 ones. Is there any 8 ones in the square boxes? Like rectangle, like 8 ones are there in a rectangular shape. So no 8 ones are there. Next step is 4 ones. Is there any 4 ones? Yes. There are 2 possibilities to 4 ones. First we will check this one. So this is one prime implicant group. Adjacent ones make this quad. And then in order to cover the remaining 4 bits, so first priority is 16, there is no 16. And the second priority is 8 ones, there will be no 8 ones. And third priority is 4 ones. Is there an adjacent 4 ones to cover this one? Yes, we can take that one, like this is the 4-1 adjacents. This is the 4-1 adjacents. Otherwise we can take the shape is, we can take that shape is like a 4 corners. We can cornerize that one. 4 corners. There is 4 corners is one group, 4 ones. So there are one left, one is left. In order to cover that one, is there any 4 ones cover to make this one as a group? No 4 ones. So only pair is there possible. So in order to do that one, we can make pair. So the first 4 one, F is equal to, so this is the first group of quad. So horizontally, what are the common variable? 1, 1, 1, 0. 1 is the common, means W. And vertically, last third column and fourth column. Among third and fourth, what is the common variable? 1, 1, 1, 0. Y is common. So W is Y. And the second group of implicant, all 4 corners, horizontally, first row and fourth row, 0, 0, 1, 0, common variable is X bar, and first column and fourth column common variable is Z bar. This is one term. And next pair, last one is pair. So only one row, that row can be considered W bar, X bar. What is the common variable between first column and second column is 0, 0, 0, 1, Y bar is the common. So 3 terms. So according to K-map, we can get the 3 prime implicants. Even we can take the tabulation method, we can get 3 variables. By comparing these two, we can get the correct answer. You can check whether it is correct or not. Next, in order to identify that, even first step of exhaustive search will also possibility to further minimization by go to second step. That one will see direct prime implicant in the second example. In this example, we can consider that a decimal number representation of all the groups, and we no need to check in that way, but we can check what are the unmarked groups to get the prime implicant. What is the unmarked groups in the prime implicant is this one, and this one, 3 or 4, 5. This is same, 8, 9, 10, 11. So 1. So total is 6 prime implicants. What are those 6 prime implicants are? We can see here. What are those 6 prime implicants? 1-9, 4-6, 6-7, 7, 15, 11, 15, 8, 9, 10, 11. These are the 6 groups. These 6 groups will make 6 prime implicants, which is corresponding binary representation in second column and its corresponding variable representation in third column. These are the 6. Is these 6 minterms is the final minimized Boolean function? No, we can check the further prime implicant table. That further prime implicant table is take the 6 prime implicants now in the column, first column, prime implicant, take the prime implicant in the first column and its corresponding groups, decimal numbers groups in this column. Just beside this prime implicant, we can represent what are the groups which cover this prime implicant. And next, second column, we can take the minterms. We can take minterms. In this minterms, in the problem given 1, 4, 6, 7, 8, 9, 10, 11, 15 are the minterms in the Boolean function. So 1 is in the first prime implicant is covered by 1, so we can take cross mark, and 9 is also there, we can take cross mark. The second prime implicant 4, 6. In order to cover this prime implicant, we can have 4 and 6. Likewise, third prime implicant cover 6, 7. Take cross mark 6, 7. Next 7, 15 for the 4, 7, 15, and 11, 15 in fifth prime implicant, and 7 like 6th and 7th prime, 6th prime implicant. It covers 8, 9, 10, 11. This cross mark represents that what are all the numbers, decimal numbers, prime number, like minterms numbers covered for the prime implicant. Next, who are the essential prime implicant? Who are the essential prime implicant in this case? The essential prime implicant, single cross mark in the entire column, are called essential prime implicant. Here it is essential. This is one single cross mark. This is one single cross mark. They are called essential prime implicant. So, what are all the prime implicant which covers essential prime implicant? Essential prime implicants are related with the prime implicants. Now we will see what are the prime implicants which will be counted to final minimized Boolean function from essential prime implicant. First essential prime implicant, this one. This prime implicant cover this prime implicant, like this essential prime implicant is covered this first prime implicant, and the second this one is the another essential prime implicant. This essential prime implicant covered to second prime implicant, and another prime implicants. These are same row. These two prime implicants are covered in the last prime implicant. These two essential prime implicants are covered by last prime implicant, so we can tick mark. Now, how many minterms are there now remaining left? Third, fourth, fifth. Third, fourth, fifth are the remaining prime implicants are left. So we can consider final 3 prime implicants up to now. Now, check that is there any columns left with this cross mark. So first, this one is this prime implicant covered first prime implicant. This cross mark covered second prime implicant. This 6 and 6, these 6 numbers. So here it is this cross mark covered to the second prime implicant. So this is also covered. 4 is covered. 8 is covered in third last prime implicant. 9 is also grouped this one, so we can cover. 10, this is there covered in the third prime implicant. And 11, these two cross marks are one among the cross mark. This cross mark covered to this is the corresponding row in the third prime implicant, minimized prime implicant. And 15, this is the, if you see this 15, this belongs to last sixth prime implicant, so not covered. And 7, this one, they are not covered. Not covered prime implicant, under not covered prime implicant, so we can not tick by this 7 column and 15 column. So whatever the minterm columns which are not covered in any of 3 minimized prime implicants, then those columns also to be considered as a final minterms, like to be considered as included in the expression. So in order to including this 7 minterm and 15 minterms, now we can take its corresponding prime implicants. What is the 7 cross mark? Its corresponding. So simply we can say that 7 and 15s are, so already 1, 4, 8, 10 are these essential prime implicants are make the minimized Boolean functions as x bar, y bar, z plus w bar, x, z bar plus wx bar. But here this 7 and 15 are, these columns are not marked. They are not belongs to any of those prime implicants, 3 prime implicants. So they are also considered. How to consider? By taking one or more prime implicants. If they are common prime implicant, 7 and 15 are covered by common prime implicant, then consider only one prime. If they are different, covered by different prime implicant, we can separate 2 prime implicants to be considered. So what is the 7? For example, if you see here, 7 and 15, these 7 and 15 are covered in the same prime implicant xyz. So we can consider single prime implicant considered in the final answer xyz. So this is also considered. The remaining 2 are left. So this one is considered, this one is minimized prime implicant, this one is minimized, this one is minimized. Remaining 2 are not considered. Then final answer is x bar y bar z plus w bar x z bar w x bar x y z is the final minimized Boolean function. Only 4 minterms, only 4 prime implicants are should be considered among 6 prime implicants finding from the exhaustive search. So that is how to finding from the tabulation method. But remember it, if when we fail to perform the step-by-step process, along the way when we missing any one step, then we will get into problem. So that is the thing. So that's it how to find out the minimized Boolean function from the Quine McCluskey method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.